Integration by partial fractions. Recall that a rational function is defined as the ratio of two polynomials in the form px by qx, where px and qx are polynomials in x and qx is not equal to 0. If the degree of px, remember that if the degree of px is less than the degree of qx, then the rational function is called proper, otherwise it is called improper. The improper rational functions can be reduced to the proper rational functions by long division process. Thus, if px by qx is improper, then px by qx equal to tx plus p1x over qx, where tx is a polynomial in x and p1x by qx is a proper rational function. So, this we have seen in class 9th. As we know how to integrate polynomials, the integration of any rational function is reduced to the integration of a proper rational function. The rational functions which we shall consider here for integration purposes will be those whose denominators can be factorized into linear and quadratic factors. Assume that we want to evaluate integration of px over qx dx, where px by qx is proper rational function. It is always possible to write the integrand as a sum of simpler rational functions by method called partial fraction decomposition. After this, the integration can be carried out easily using the already known methods. The following table, that is table 7.2, indicates the types of similar partial fractions that are to be associated with various kinds of rational functions. So, this is table 7.2, and here you can see that all the rational functions given here are proper. Why? Because in proper rational functions, first of all, the numerator and denominator both should be polynomial. So, here this polynomial and multiply this will also become a polynomial, and the degree of the numerator should be always smaller than that of the denominator, not equal, so it should be smaller than. If it is equal or bigger, you have to divide it by long division method. So, here you can see the degree is 1 in the denominator, degree is 2. Similarly, here degree is 1, degree of the denominator is 2. Here degree of the denominator will be 3 and degree of the numerator is 2. In this case, again degree of the numerator is 2 and that of the degree is the denominator is 3. That is the degree means here the highest power of x. So, in fifth one, you can see that the highest power of x is 2 and the highest power of x, the denominator will be 3. So, they all are proper rational functions and they can be partially factored as this one. This is the form of partial fractions. A by x minus first one, if we have a rational function of the form px plus q over x minus a into x minus b, we can rewrite in the form of partial fraction as a by x minus a plus b by x minus b. Why we are writing this? Because when we obtain the value of capital A and capital B, we can easily integrate this because we know what is the integration of 1 by x. So, this will be a into log of x minus a plus b into log of x minus b. Very simple one. Similarly, the second one, that is px plus q over x minus a whole square, that can be written in form of partial fractions as a by x minus a plus b by x minus a whole square. Similarly, we have the third one, that is px square plus qx plus r over x minus a into x minus b into x minus c equal to a over x minus a plus b over x minus b plus c over x minus c. So, if there is a cubic polynomial, then we have to first rewrite that in the form of factors as here given, x minus a into x minus b into x minus, then only you can apply. Directly we cannot apply this form. So, our rational function should be exactly of this form. If it is not of this form, then we have to rewrite in this form to apply this form of partial fractions. So, now fourth one, px square plus qx plus r over x minus a whole square to x minus b, that can be written as a by x minus a plus b by x minus a whole square plus c by x minus b. And fifth one, px square plus qx plus r over x minus a into x square plus bx plus c. That means when the second part in the denominator is not factored, is not cannot be factorized further. So, in that case, the partial fraction will be a by x minus a plus bx plus c over x square plus bx plus c. It is to be important here to be noting that bx plus c should be over x square plus bx plus c, that is that part of the that quadratic polynomial which cannot be factorized further. So, over that what we will write bx plus c. So, if we remember all this table 7.2, then we can easily integrate any of the rational functions which are proper. So proper rational functions are can be easily integrable, uh, can be integrated by this, and if it is not proper, then we have to divide it, and then this form of partial fraction can be applied to integrate it. So what we will be doing now is we will go in exercise and work out this with the help of this table. We will solve the integration problems. So exercise 7.5, let us do question number 1. So solving question number 1, solution 1. So first one is we have to integrate here. We have to integrate to find integration of x over x plus 1 x plus 1 into x plus 2 dx. So if you want, we can directly also solve it by the earlier method, that is integration of px plus q over ax square plus bx plus c. We know how we have done that one in the earlier exercise, or we can use partial fraction here. So first of all, we'll see out of the table that which form is this one. So let us go back to the table number 7.2. So table 7.2, here we are having, and if we match, we try to match with 1, 2, 3, 4, 5 of all the forms. So this is of the first form. So it's very simple. What we'll do is we'll write this x over x plus 1 into x plus 2 in the form of a by x minus a plus b by x minus b. So let us write this in that form. That is what we'll write. Let x over x plus 1 into x plus 2 equal to a over x plus 1 plus b over x plus 2. Here we can take any of them. Here if you want, we can write a over x plus 2 also and plus b over x plus 1. Our final answer of integration will not change. So this a and b can be interchanged. It's not such a big problem. So now let us we'll solve this further so that we can get the value of capital A and capital B. So what we'll do is we'll keep the left hand side as it is, x over x plus 1 into x plus 2 equal to, here we can cross multiply and we'll be getting a into x plus 2 plus b into x plus 1 over x plus 1 into x plus 2. Now both sides in the denominator we are having x plus 1 into x plus 2, so that will cancel out. So next step, what we are getting is x equal to, we can simplify the right hand side, we will be getting ax plus 2a plus bx plus b. So next step, x equal to, group all the terms containing x terms, so that will be a plus b into x plus constant will be 2a plus b. Now what we'll do, we'll compare both sides. X has to be compared with x and constant will compare with constant, but here there is no constant, that means constant on the right hand side is 0. So that means 2a plus b will be equal to 0 and a plus b will be equal to the coefficient of x, which is 1 here. Therefore on comparing we have, what we are having on comparing, 1 equal to a plus b, let this be equation number say 1, and we'll compare 2a plus b with a constant on the left hand side, but there is no constant on the left hand side, that means the constant is 0. So we'll be getting 0 equal to 2a plus b, let this be equation number 2. Now we can use elimination method so that b will be eliminated. So minus, minus and minus, eliminating b. So what we are going to get is 1 minus 0, that is 1 equal to a minus 2a, that is minus a. So therefore a equal to minus 1. So what we have got, a equal to minus 1. Now we will put this value of a equal to minus 1 in equation number 1. So putting a equal to minus 1 in equation 1, we have, now what is equation 1? A plus b is equal to 1. So therefore, in place of a, we will put the value of a, that is minus 1 plus b equal to 1. Therefore, we will get b equal to 1 plus 1, that is b equal to 2. Therefore, b equal to 2. So we have got b as 2 and a as minus 1. So now what is our task? Our task is we'll just put that this value in place of this a and b, and then we'll be able to integrate this function. So therefore, we can say that therefore, now what is our question? Let us go back in that one. This one. Therefore, x over x plus 1 into x plus 2 equal to, we have written here, if you see it, that we have written a over x plus a plus b over x plus 2. So a over, in place of a, will put the value of a, that is minus 1 over x plus 1 plus b over b is 2 over x plus 2. Therefore, integration of x over x plus 1 into x plus 2 dx will be equal to integration of minus 1 over x plus 1 dx plus integration of 2 over x plus 2 dx. And we know that what is the integration of 1 by x, that is log x. So we will integrate this. So equal to minus 1 over integration of this will be log, this will be getting minus 1, integration of 1 by x plus 1 is log x plus 1, so we will be getting minus there, so that can be taken out of the integration, so we will be getting minus 1 log mod of x plus 1 plus 2, and here also we will be getting log mod of x plus 2 plus c. And we know that this can be this one rule, if you remember all, it is like this, a log m is equal to this, a outside the log can be taken inside the log, and we can write it as log m raised to a. So this form will apply. So we can rewrite this one equal to, this minus will take inside, so it will become log mod of x plus 1 raised to minus 1, and this will become plus log x plus 2 square plus c. Here there is no need for mod because it is x plus 2 whole square is positive quantity. So next one, what we will be doing is that we will be applying the formula, that is log a plus log b is log a into b. So this can be written as equal to log a into b, that is log x plus 1 raised to minus 1 into x plus 2 whole square, and mod will be there plus c. As I told you, here mod is not required because x plus 2 whole square is positive, but x plus 1 may be negative also, so we will be putting mod overall. So now this further can be written as, we know what is a raised to minus 1, that is 1 by a, so equal to log x plus 2 whole square over x plus 1, so mod of this plus c. So this is the answer of our integration. So with this, question number 1 is complete. Now we will be doing question number 2, that is integration of 1 by x square minus 9. So solving question number 2, here we can use directly the formula of 1 by x square minus a square also, but we will be using here partial fractions. So what we can do here in this case is, first of all, 1 by x square minus 9 we can write as 1 by x square minus 3 square, and we'll do the factorization of this. This can be written as, therefore 1 by x square minus 9 equal to 1 by x minus 3 into x plus 3. So now we can see that this can be written as, therefore 1 by x square minus 9 can be written as a over x minus 3 plus b over x plus 3. What is this? This is our first form. See the table exercise 7.2, we'll come to know that. What is this form? Here px plus q, even p can be 0 also, so it will be q over x minus a into x minus b. That is can be written as a over x minus a plus b over x minus b. So this is the form. 1 by x square minus 9 can be written as, first of all we have done the factorization of this as in this form x minus a into x minus b form, and then we have written 1 by x square minus 9 as a over x minus 3 plus b over x plus 3. Our next task is to obtain the value of a and b. So how we can do? We'll just simplify this. So therefore we'll get 1 over, keeping the left hand side as it is, equal to a into x plus 3 plus b into x minus 3 over x minus 3 into x plus 3, that is x square minus 3 square, that is x square minus 9. So again I just want to repeat that you can use directly the formula of 1 by x square minus a square also. So this is only just to learn the method of partial fraction. We are doing this way, but it's not necessary that you follow these steps only. So now next we will be trying to obtain the value of a and b. For that we can see that in the denominator both side we are having x square minus 9, so that can cancel out. So therefore we are getting 1 equal to, if we have to group x terms together, so we will be getting a plus b into x, and plus here if you solve it we will be getting 3a, and here we will be getting minus 3b. We will put 3a minus 3b together because it is a constant part. Now if you see the left hand side, there is no x term, that means the coefficient of x should be 0. So therefore on comparing we have a plus b equal to 0. So this is our first equation, and second one we can see that we are having the constant part in the left hand side is 1, and in the right hand side we are having 3a minus 3b. So that means 1 should be equal to 3a minus 3b, or we can write 3a minus 3b equal to 1, or also we can rewrite this as a minus b equal to 1 by 3. So let this be equation number 2. Now what we'll do, we'll solve 1 and 2. If we just we'll solve them by elimination method. So adding 1 and 2, if we add them, b will be eliminated. Adding 1 and 2, we have, can subtract also. Adding 1 and 2, we have a plus a is 2a, so we will be getting 2a, and plus b minus b will cancel each other, so we will be getting 2a equal to 0 plus 1 by 3, that is 1 by 3. Therefore what is our value of a? A will be equal to 1 by 6, and also if you put the value of a equal to 1 by 6 in 1, so putting this in 1, what is a plus b equal to 0? That means a and b are of opposite sign, so b will be equal to minus a, therefore b equal to minus a equal to minus, value of a is 1 by 6, so minus 1 by 6, so this is the value of b. So therefore what we are getting, b equal to minus 1 by 6. So now we can easily integrate our question number 2. So we will be integrating question number 2. Here we are having integration of, therefore integration of 1 by x square minus 9 dx equal to, so how we have done the partial fraction, let us go back, that is a over x minus 3 plus b over x plus 3. So we will be writing that equal to integration of a, what is a, 1 by 6, that we can take out, constant can be taken out, over 1 by x minus 3 dx, plus what is the value of b, b over x, a over x minus 3 plus b over x plus 3. So b is our minus 1 by 6, so that we can take out of the integration. Then 1 over x plus 3 dx. Now we'll integrate this further, so equal to 1 by 6, which will become log of mod x minus 3 plus, here plus minus will be getting minus 1 by 6 and that can be written as log x plus 3 mod plus c. From both the terms we can take out 1 by 6 common, so we will be getting equal to 1 by 6, in bracket we will write log mod of x minus 3 minus log modulus of x plus 3 and in bracket close plus c. Now we know that log a minus log b is log a by b, so this we can rewrite as equal to 1 by 6 log modulus of x minus 3 over x plus 3 plus c. So this is the answer of question number 2. So with this, question number 2 is complete. Now exercise 7.5, question number 3. So what is question number 3? We have to integrate 3x minus 1 over x minus 1 to x minus 2 into x minus 3. So let us go back to table 7.2 and let us see in which way the partial fraction can be done. So table 7.2 is here now, and we can see that here px square plus qx plus r over x minus a into x minus b to x minus c equal to, so this is the form, because the coefficient of x square can be 0, even the coefficient of x can be also 0, so there is no problem in that. In the numerator in the numerator the polynomial can be quadratic or linear, even it can be constant polynomial. There is no restriction on that. And in the denominator we are having cubic polynomial, but it is factorized, so that is why we are getting of the form x minus a, x minus b, x minus c. So we will be applying this form, that is px square plus qx plus r over x minus a into x minus b into x minus c equal to a over x minus a plus b over x minus b plus c over x minus c, and then we will obtain the value of capital A, capital B and capital C. So this is the form which we have to apply in exercise 7.5, question number 3. So let us do question number 3, solution 3. So let 3x minus 1 over x minus 1 into x minus 2 into x minus 3 equal to, this can be written as a over x minus 1 plus b over x minus 2 plus c over x minus 3. Now simplifying it, we will be getting, we will keep the left hand side as it is, therefore 3x minus 1 over x minus 1 into x minus 2 into x minus 3 equal to, we will be getting a into x minus 2 into x minus 3 plus b into, b will be x minus 1 into x minus 3. Why? Because the LCM in this case will be x minus 1 into x minus 2 into x minus 3. So we will be getting a into x minus 2 into x minus 3 plus b into the other, not take the quantities below which is under b, that is x minus 2. So we will multiply b with x minus 1 and x minus 3. Similarly will be the case with c, plus c into x minus 1 into x minus 2 and the whole divided by x minus 1 into x minus 2 into x minus 3. Then both side cancelling, x minus 1 into x minus 2 to x minus 3 in the denominator. So remaining what we will be getting is 3x minus 1 equal to a into, just simplify it here, we will be getting here x square, then minus 3x minus 2x, this will become plus 6, then plus b into, then we will be getting x square minus 3x, x square minus 3x minus x plus 3, then plus c into x square minus 2x minus x plus 2. Now in the right hand side we will add the like terms, so we will be getting, therefore keeping the left hand side as it is, 3x minus 1 equal to a into x square minus 5x plus 6, then plus b into x square minus 4x plus 3 and plus c into, we will be getting x square minus 3x plus 2. Now what we'll do is we'll group the terms which contain x square together and the term which are having x and the constant term all them separately. So therefore 3x minus 1 equal to grouping x square terms together. So we will be getting a plus b plus c into x square. Then plus we can write x into coefficient of x will group together, that is minus 5a, then minus 4b, and we are having here minus 3c. And now grouping the constant terms together, so plus 6a plus 3b and plus 2c. Now if you see the left hand side, there is no x square term, that means the coefficient of x square is 0. So on comparing both sides, what we will be getting is a plus b plus c equal to 0. On comparing both sides, so therefore on comparing both sides, we have what we are having as discussed, the coefficient x square is 0, so we will be writing a plus b plus c equal to 0. And then here on the left hand side the coefficient of x is 3, and on the right hand side the coefficient of x is minus 5a minus 4b minus 3c. So it simply means that minus 5a minus 4b minus 3c is equal to 3. So that is what we will write, minus 5a minus 4b minus 3c equal to 3. And now compare the constant term. So constant term will be getting minus 1 equal to 6a plus 3b plus 2c. So this is what we are getting, and now we'll solve them to obtain the value of capital A, capital B and capital C. Now we'll be solving this on the next page because the calculation work is more. So let us write down this all in the next page. So we'll be getting here a plus b plus c equal to 0 and minus 5a minus 4b minus 5a minus 4b minus 3c equal to 3. So minus 3c equal to 3 and minus 1 equal to, or we can say that 6a plus 3b plus 2c equal to 6a plus 3b plus 2c equal to minus 1. So what we have got here is a plus b plus c equal to 0, that is what we are having, and minus 5a minus 4b minus 3c equal to c, and 6a plus 3b plus 2c equal to minus 1. So these are the equations, and let them be say 1, this be 2 and this be 3. Let's go back and check if we have given any number 1, 2, 3 earlier or not. So we have not given any, so we can take the equation number as 1, 2 and 3. Now we'll be solving them on full page, so it will be easier for us. So now what we can do is we'll first eliminate a. So let us eliminate a from say, for that what we can do, we can take the value of a from equation number 1. So from 1, a equal to, what is a? A is equal to minus b minus c, and let this be fourth. So we'll put the value of this value of a in 4 this fourth one in equation number 2 as well as equation number 3, so that a will be eliminated. In place of a, will be getting only terms with b and c form. So putting 4 in 2, first we'll put 4th in 2 and then in 3. So putting 4 in 2 will be getting minus 5. In place of a, now we'll be putting minus b minus c and minus 4b minus 3c equal to 3. So let us simplify it. We'll be getting minus minus, that is plus 5b, and this will become plus 5c minus 4b minus 3c equal to 3, and this will become 5b minus 4b, that is b, 5c minus 3c, that is plus 2c equal to 3, and this will be our equation number 5. So writing this as equation number 5. Now next what we'll do is we'll put 4 in equation number 3. So putting 4 in equation number 3, putting fourth in equation number 3. So we'll be having 6 in place of a. We'll put the value of a as minus b minus c. 6 into minus b minus c plus 3b plus 2c equal to minus 1. So this will become minus 6b minus 6c plus 3b plus 2c equal to minus 1. Adding the like terms, minus 6b plus 3b, that is minus 3b, minus 6c plus 2c, that is minus 4c equal to minus 1, and this will give us 3b plus 4c equal to 1, and let this be equation number 6. Now what we'll do is we'll solve we'll solve equation number 5 and 6 by the method of elimination, and then or we can use substitution method also, and then we'll be able to get the value of b and c. So solving 5 and 6, solving 5 and 6. So we are having here b plus 2c equal to 3, and this will give us 3b plus 4c equal to 1, and we can rewrite them as, therefore we have, this implies we can multiply both sides with 2, so we will be getting 2b plus 4c equal to 6 and 3b plus 4c equal to 1. Now let us do the subtraction work so that c will be eliminated. Subtracting this, will be getting 4c and minus 4c cancelling each other. 2b minus 3b, that is minus b, equal to 6 minus 1, that is 5. So therefore we can say that, therefore b equal to minus 5. So b is minus 5. Now we can put the value of b in either equation number 5 or equation number 6. So suppose this is 7th one. So putting 7 in equation number 5, let us put in equation number 5, putting 7th one in equation 5, we have, so let us put the value of b equal to minus 5. So what is b equal to minus 5? So minus 5 plus 2c equal to, b plus 2c equal to 3. So that is, we are getting minus 5 plus 2c equal to 3. Therefore we will get 2c equal to 3 plus 5, that is, therefore 2c equal to 8, or we can say that c is equal to, therefore c equal to 4, and let this be 8th one. So we have got b equal to minus 5 and c equal to 8. So now again we will go in a new page because the calculation still is somewhat more. So what we have got is c equal to, here we have now c equal to 4. So c we have got 4, and we have got b equal to minus 5, b equal to minus 5, and we want to obtain the value of a. So let us go back in our equation. We are having here a plus b plus c equal to 0. That is what we will write. Also a plus b plus c equal to 0. Therefore a plus, we just will put the value of b and c, plus 4 plus minus 5 equal to 0. That means a plus 4 minus 5 is minus 1, a minus 1 equal to 0. Therefore a equal to 1. So what we are getting? We are getting a equal to 1, b equal to minus 5 and c equal to 4. So now we can do the integration work. So we'll integrate this. So now let us see what will be our final integration. Therefore, integration of 3x minus 1 over x minus 1 into x minus 2 into x minus 3 dx equal to, so we have written this one as, if you see the first one, initially if you see that here we have taken a over x minus a plus b over x minus 2 plus c over x minus 3. There is a is over x minus 1, b is over x minus 2 and c is over x minus 3. So that is what that is how we are going to rewrite this our function which is to be integrated. So equal to integration over a over x minus a, what is a? 1 over x minus 1 dx plus now b over x minus 2, what is the value of b which we obtained? B is minus 5. So minus 5 over x minus 2 dx plus c. So plus integration of c over x minus 3. So what is c? C is our 4. So plus 4 over x minus 3. So we are integrating 4 over x minus 3. Now we'll further simplify it. Equal to, we know what is the integration 1 by x, that is log x. So it's equal to log mod of x minus 1. And this minus 5 can be taken out of the integration. So we'll be getting this as minus 5 log mod of x minus 2 and plus 4 log mod of x minus 3 and plus c, and this we can write as equal to log x minus 1, then this minus 5 can be taken inside, so that will become into x minus 2 raised to minus 5 and into plus 4, this 4 also can be taken inside and can be written as x minus 3 raised to 4 mod will be closed plus c. Why? Because we know that if you take it minus 5 will be inside, then we will get form of the type log x plus log y plus log z, and there is log xy in log xyz. So that is what we have written here, and now can further simplify it. Equal to, this will become log mod of x minus 1 into x minus 3 raised to 4 over x minus 2 raised to 5, and modus symbol is there plus c. So this is our final answer. So with this, question number 3 is complete. So this is the solution of question number 3. Now exercise 7.5, question number 4, that will be for self trial. Question number 4 for self trial, and it's to be done in the same way as we have done question number 3, same way as question number 3, same as question number 3. So you will try on your own, and then we have question number 5. Question number 5 is also a very simple one. It is to be done the same way as question number 1. Question number 5, that is again for self trial, and it is to be done as same as question number 1. What you have to do is just factorize, just factorize the denominator, just factorize the denominator, factorize the denominator. So that is the hint for you. You have to use you can use splitting the middle term x square plus 3x plus 2, do the splitting of that and write it in the form of factors. Factorization we have to do that, already you know how to do the factorization of quadratic polynomial. And this question number 6 will be also your homework, that is for self trial. So question number 6 you will do on your own. Question number 6 is also not difficult at all. Question number 6, what you do is just because if you see that right now it is not here you can see that the degree of numerator and denominator are equal. So the degree of numerator should be always smaller than the degree of denominator. So right now this is not question number 6 is not in proper fraction form. So we'll this improper fraction, so we'll make it a proper fraction. Just how we can do it, just we'll do the separation work. We'll separate this. So question number 6 you can rewrite as 1 by 1 minus x square over x into 1 minus 2x can be written as equal to 1 by x into 1 minus 2x minus x square, that is x into x over x into 1 minus 2x. So here x and x is cancelled out. So you can see that the first part is clearly what we can say is a proper fraction, and the second part is still not a proper fraction. So what we can do in this case is can either divide or just simplify it somewhat more. This can be written as 1 by x into 1 minus 2x. We know how to integrate this minus, because this we are having here minus 2x, so plus we can take here, minus we will take inside with x, so it will become minus 2x over 1 minus 2x. Then add 1 and subtract 1. Adding 1 and subtracting 1, because we are adding 1 and then we will be subtracting. Again we will do the separation work. So equal to, here we have multiplied with 2 and is to be multiplied and divided by 2. So this 2 should be coming here also. So equal to 1 by x into 1 minus 2x and plus this will become 1 minus 2x over 2 into 1 minus 2x and minus 1 over 2 into 1 minus 2x. So 1 minus 2x and 1 minus 2x will be cancelled out, and what we will be getting in this case is, if we solve this, equal to 1 by x into 1 minus 2x plus 1 by 2 minus 1 over 2 into 1 minus 2x. So integration of second part and third part is very simple, and this first part again you can see the table 7.2 and do it in the this resembles the first form. So this question number 6 will be also for your self trial, you will be doing on your own. It's not difficult at all, just try it and you will be able to get the answer surely. So question number 6 will be for self trial, that is you have to do on your own. Question number 6, self trial.